Key skill 7 looks at unknowns inside the binomial expansion. So far, we've only looked at binomial expansions with numbers. What do you do if you get a K or a letter inside the expansion? Well, you do pretty much exactly what we've been doing the whole time. So we've been asked to find the expansion of 1 plus kx cubed. The coefficient of x is the same as the coefficient of x cubed. So what would the expansion look like? Well, we'd start it out just like we had done before. Again, we don't need this column because 1 power anything is always 1, but let's keep it nice and neat. So I'm going to start kx on power 0, and I'm going to increase it up from 0 to 1 to 2 to 3. Now let's think. Everything here is going to be 1. So 1 times 1 times 1 is just 1. This would be 3. If you don't remember, use your calculator. 3 times 1 squared times kx would be 3kx. Now here, don't forget, we have 3 times 1. Both of these things inside the bracket need to be squared. So it would be 3k squared x squared. And this would be 1 times k cubed x cubed. So I always write my expansion out at the end. Now we can solve the equation. We've been told the coefficient of x, so the coefficient of x is this one, is the same as the coefficient of x cubed, so this one. So that means that 3k is the same as k cubed. We can bring everything to one side, and we can factorize. Now we can solve this equation to give, we'll have 3 values for k. K could be 0, or we could have k squared equals to 3, and k would be plus or minus the square root of 3. We're told in the question that k is bigger than 0, so we would eliminate the solutions k is equal to 0 and k is equal to the negative square root of 3, and we'd be left with our last solution, which is k is equal to square root of 3. Guys, if you're still with me and you've been listening from the beginning, good job. We've got one question left. It's a little bit tricky, but you're going to get through this. If you're feeling a little bit nervous about what we learned in Key Skill 1 and Key Skill 2, I would go back and revise that now because you're going to need all of that information in this question. The question says, find the first 4 terms in the coefficient. Let's get going. We need the first 4 terms. Now, the difference between this and all the other questions we've seen is we have an n there. So here we would have n choose 0. We want the first 4, right? The trick is in this question to start the ones on the n and work backwards on the ones. And the reason why that is that 1 power anything, including n or 1 with a power in terms of n, is still going to be 1. And that leaves us with x's with actual numerical powers. Okay, now to do this question, you're going to want to know, or you're going to want to remember that n choose 0 is always 1. So this question would be 1 times 1 times 1. So it would be just 1. Now you need to remember that n choose 1 was just n. So this would be n times 1 times x. So it would be nx. If you don't remember that, then we need to remember that n choose 1 was n factorial, 1 factorial, top minus bottom, n minus 1 factorial. We open out the top as far as the bottom. Oh, that again I hear you saying. And we can cancel that down. So that would be nx. We're going to use the same trick for n choose 2. So that would be n factorial, 2 factorial, which is 2, 2 times 1, n minus 2 factorial. So open up the top, n minus 1, n minus 2, and then cancel. So this would leave us with n squared minus n divided by 2 when we multiplied out the bracket. We're going to repeat that process for the 4th and final term. So So keep opening it out, subtracting 1 each time. Three factorial is 3 times 2 times 1, so it's going to be 6. So we can do that one. I might actually remember that it's actually much easier in the next step if you leave these multiplied, these as brackets. I'm going to leave that like that actually. So if you wanted to multiply this out, this would be n squared minus 2n minus 1n plus 2. So it'd be minus 3n plus 2 over 6, and you would have n cubed minus 3n squared plus 2n. But remember what I said, for the next step it's easier to use the bracket. So that would be the expansion. Your expansion in the case that you have n as a power is going to be in terms of n. That means each answer has n in the inside, not just x, but n also. So these are the first 4 terms. 1, 2, 3, 4. The question tells us that the coefficient of x to the 4 will be the same as x to the 2. X to the 2, we've already got it here. Now, x to the 4 coefficient would be the next one, which would look like this. Would be n choose 4, which would be n factorial, 4 factorial, n minus 4 factorial. Now, I'm going to leave it like this. This wasn't required in the expansion, so we don't need to multiply out. So we're told that this one is the same as x squared. Now, the x squared coefficient was n choose 2. So we've basically been told that n choose 2 is the same as n choose 4. So if we go back and we look, the coefficient of x squared was n minus 1. It's easier to use it in the form before we multiplied out the brackets. Divided by 2. And this one is going to be n minus 1, n minus 2, n minus 3, divided by 24. The reason why I say it's easy to use it in the form before you expand the brackets is you can now just cancel n for n and n minus 1 for n minus 1. Now we can cross multiply. So we would have here 24 is equal to 2 times n minus 2, n minus 3. I'm going to divide both sides by 2. So 12 is equal to n minus 2, n minus 3. Multiply that out. And bring the 12 to the other side. So that gives us minus 5n minus 6. Factorize. So we'd need minus 6 and plus 1. And solve. So we'd get n equals to 6 and n equals to minus 1. We couldn't have a minus number in this context, so we know the answer is n equals to 6. There is a really great variation on this question in the website with not only a coefficient outside, but a coefficient inside. So I would really recommend that you look at that question. I hope you've enjoyed this series. I don't know which shows I'm going to make next. Write down below in the comments what videos you would like to see from me. Like, subscribe, and I will see you in the next series. Bye for now, guys.